Chapter 2, Final Exam. For those of you who are watching this video, you're probably making your corrections. Remember, when you make your corrections, for all the questions you had wrong, let's say you had this question wrong. Question 1. On one half of your paper, you're going to write what I did. And you're going to show me what mistake you made. And then over on the other side, what I should have done is what you're going to have. And you're going to write the solution for what you should have done to show your work correctly. And you're going to do this for all of the questions you had wrong. Okay? Then you're going to submit that piece of paper, and then on Tuesday, you will be eligible to write a retest. If you don't do this sheet, you can't write a retest. It's pretty easy. So your first question is true or false. It says -3 1/5 is equal to -3 1/2. Well, really what that's asking is, do you know how to change a mixed fraction into a decimal? And since 3 1/5, -3, so you know it's -3 and whatever 1/5 is as a fraction. So if you didn't know that 1/5 was decimal 2, you could take the numerator 1 and divide it by the denominator, which is 5, and you get 0.2. So 3 and 1/5, let me just grab my eraser here. 3 and 1/5 is the same thing as 3 and 1/5, or 2/10. So therefore, the answer is true. They are the same thing. And there's your work to show it. You said you just converted it to a decimal. Or you could have actually taken this and said, well, that's -3 and 2/10, which is equal to -3 and 1/5 if you wanted to. That would also be a good solution. Question 2, 0.2 repeating. It's a decimal between the fractions -1/4 and -1/5. So -1/4, if I was to make a number line, -1/4 would also be -0.25. That's a -1/4. And -1/5 would be -0.25. Actually, I have these backwards, don't I? Because they're, sorry, -0.2. No, I don't. They're perfect. Because they're negative, as we go this way, you're going to get closer and closer to 0. Okay. So -0.2 repeating, -0.2 repeating is the same thing as -0.2222 ... to infinity, which if I put a 0 here just to show you, this number would actually fit into this number line right around here. So -0.2 repeating is a decimal, and therefore the answer is true. Okay. So what you probably wanted to show for work was this here. And in fact, you probably don't need this part here. But that would be probably enough work to show that you knew that 0.2 repeating is a decimal between those. Question 3, all answers must be supported, true and false. This one's actually really easy. A negative plus a negative, no matter what your negatives are always going to be negative when you add them together, because a -2.2 plus a -0.7 is going to be -2.9, but it doesn't matter what it is, it's going to be that. And then if I say a negative divided by a negative, using our sign rules, a negative divided by a negative always going to be a positive. And therefore, a positive will always be greater than a negative, and therefore, our answer is true. It doesn't matter actually what the quotient is or what the answer is to this. We know it's going to be positive. And it doesn't matter what the answer to this is. We know it's going to be negative. And therefore, we can clearly say that a negative will always be less than a positive. And question 4, good estimation for this is -4. So here, if I think about estimating, I'm going to say 1 divided by -4. And if you think about this, I have $1 divided between 4 people. Everybody does not get $4. Everybody would get 0.25. So it is approximately equal to 0.25. And therefore, your answer is false. A good estimation would be 0.25. I would say half the class thought that 1 divided by 4 was 4. We're out of the true false. We're into our reordering of rational numbers in ascending order. So the first thing I'm going to do is I'm going to convert all of these to the same form, either all fractions or all decimals. And when we studied this, we agreed that writing them all as decimals is probably the easiest thing. So -1 or -7/5 is -1 2/5, which is -1.4, right? If I didn't know that, I could just take my numerator 7 divided by my denominator 5, and it still tells me -1.4. And this is -1.75 terminating decimal or ceasing decimal. So on a number line, if I put 0 here, and I put -2 here, and I put -1 here, the largest number, the closest to 0, would be -1.4, which would be roughly here, which is -7/5. So that's our largest number. Our next closest to 0 would be this one here, -1.7. -1.7. Then the next closest to 0, this is tricky because now we have terminating zeros and non-terminating. So this would be the next closest, which is -1 3/4. And our farthest from the decimal would be right here, which is -1.75, repeating. Therefore, in ascending order, from smallest to largest, our answer would be -1.75, repeating, -1 3/4, -1 decimal terminating decimal 7, and -7/5 as our largest number. Question 6 gives us greater than, less than, or equal to. So the first thing you wanted to do is change -1/8 to a decimal, which 1 divided by 8 is 1.25, or 0.125. So this is -0.125 and -0.1212. Which one is larger? The closest to 0 is, which is this one, and therefore that is the greater number. I have a decimal, I have a fraction. I'm going to change that fraction to a decimal. So change 1 divided by 20, change 8/20ths to decimal 4. So it's going to be -3.4, and therefore, since these are the same, they are equal. And this is the tricky one here. -13 over -10, and negative divided by a negative, when I convert it to a decimal, will be positive. Positive is actually 1.3. And a positive 1.3 is always greater than a -1.3, and therefore it is greater than. A lot of people said this was a -1.3, but if that was true, this would have to be nothing, and that would be a -1.3. Question 7, what two fractions with a 4 as a denominator? So lies between -1 and -2. So if I put a number line here again, it said -1. As a fraction, that would be -4 over 4 for -1. And, oh, I got these backwards. Let me just erase this and try this again. -1 would be -4 over 4. And over here, for -2, that would be -8 over 4. So any fraction with a 4 denominator that would be between there, you could have the numbers -7/4, -6/4, and -5/4. Any of those three answers would be two fractions that you could use to say that they're between -1 and -2. Question 8 is your basic arithmetic with rational numbers in decimal form. So if this question was an estimation, I would say 3 plus -3, or I might even just use front end estimation, just taking the whole number, forgetting the decimal parts. And my estimation would be approximately -1. If I was to do this question as this, I would say, what do I have more of, positives or negatives? I have more negatives. How many more do I have? Well, the difference between that and that told me the answer of -1. So therefore, when I ask this question without estimation, what do I have more of, positives or negatives? I have more negatives. How many more is the difference between your negatives and your positives, right? So I'm going to subtract them to see how many more negatives I actually have. So I have to borrow. I get 6, and I get 0. So in this answer here, I actually have 0.6 more negatives, and therefore 2.5 plus -3.1 is equal to -0.6. That's how many more negatives I have. Question 2, subtraction. Keep, flip, change, easiest way to do it. Now I have addition. What do I have more of? Positives or negatives? I have more positives. So the difference between the positives and the negatives will be my answer. Since this number has 2 decimals and this one only has 1, I'm going to put a 0 there to keep everything in place. 0 take away 5 I can't do, so I borrow. 10 take away 5 is 5. 4 take away 2 is 2. 8 take away 0 is 8. So therefore, since I have more positives, this is going to be a positive 8.25 for my solution. Another way to think of it is, if I was keep, flip, change, I have $8.50 and I owe a quarter. Therefore, when I pay off my debt, I have $8.25 left. Question 10 is multiplication. If I estimated, I'd have 6 times 3, or -6 times -3, which would be approximately -18 or +18 as an estimation. Therefore, I drop my decimals and multiply without decimals because I already have my estimation. 3 times 8 is 24, carry your 2. 3 times 5 is 15, plus 2 is 17. Since my estimation was positive 18, the only place I can put my decimal is there. And therefore, my calculation is positive 17.4. Question 11 is estimate. Okay, so forgetting the signs because a negative divided by negative is positive. I know that's going to be true. So I have this much money, which we're going to make 25 cents. Because this is how we estimated with decimals. I have 25 cents divided into piles of 1 cent, roughly. Right? The money I have 25 cents divided into piles of 1 cent. How many piles can I make? Well, if I have 25 cents in piles of 1 cent, my estimation will be just 25. I can make 25 piles. If I grab my calculator to see if my estimation was correct, 0.243 divided by 0.012, my actual calculation is 20.25, but my estimation of 25 was really good just using that idea of what money I have and the size of the piles I need to make that money into. Question 12, I know my answer will be negative because a negative divided positive is that. I have $2 divided into piles of $10. I have $2 and I have to make a pile of $10. How much can I make? Well, if the pile has to be $10 high and I only have $2, 2, 4, 6, 8, I can make a fifth of a pile. And therefore my answer is 1/5, or as a decimal, 0.2. That's my estimation. So approximately, therefore it's approximately negative 0.2 as an answer. But if I took my calculator to check, 1.9 divided by 9.83, use my positive negative symbols, wherever that is, right here. My actual answer is negative 0.19, which is really close to negative 0.20. Question 13, basic question. This is actually from the grade 7 textbook. When subtracting fractions, find the common denominator. In this case, 12 will be the lowest multiple they share. Make your equivalent fractions to each. That'll be 8/12. Take away 3/12. We said subtract your numerators and keep your denominator, and therefore your final answer is a positive 5/12. That's a grade 7 question. You should be able to get 13. Question 14 is now a grade 9 question because we're adding two fractions that are both positive and negative. First thing I'm going to do is I don't like working with mixed fractions, so I'm going to change this question to the addition of mixed fractions. The first multiple at 6 and 8 share, if I was to write this out, is actually the number 24. Therefore, 24 will be your common denominator. Create your equivalent fractions, 3/24. Negative 51/24. 17 times 3 is negative 51. And this is the step that a lot of people forgot. So in adding fractions, you're going to add your numerators and keep your denominator, which makes this negative 48/24. Is that right? No, I made a mistake. It's supposed to be a 4, isn't it? Oops, easy. It's supposed to be a 4/24. 4/24. That would be a negative 47/24, which is negative 1, and 23/24 as a final answer. Sorry about that. Negative 15, we have the addition of three fractions. It doesn't matter if there's 1, 2, or 3. We can make common denominators for all three. I'm going to change this first to negative 9/5. I'm going to change this to 16/15. So we're going to have, as equivalent fractions, positive 10/15 when I make this equivalent fraction. I'm going to have times 3 times 3, negative 27/15 as an equivalent fraction, and this isn't going to change. And this is the step that most of you forgot. Add your numerators. Keep your denominator. These two are going to be a positive 26. This is a negative 27. So therefore, when you add them all up, you end up with negative 1/15. Question 16 is the multiplication. Now you could have multiplied your numerators. Actually, we're going to put this negative sign up here. And you could have multiplied your denominators. And you would have ended up with 70 and 42, which is 112 over 168. And then you'd be like, oh crap, this is divisible by 2. That's 50. That's 56 over 84. Oh, it's still divisible by 2. Then you got 25, 28 over 42, and you're like, oh, it's still divisible by 2. And you got 14 over 21, and you thought you were done. You're like, oh no, hang on a second. I can divide both of those by 7 too, can't I? And you ended up with 2/3 as a final answer. Or, alternatively, since you learned about cross reduction, you could cross reduce this by thinking the 16 over the 8 would reduce to 2 over 1. The negative 7 over 21 are both divisible by 7, giving you negative 1 over 3. And when you multiply it all out, oh, I forgot the negative sign. You would have still ended up with negative 2 over 3 as a final answer. Number 17 is division. And when we have division, we always said it's easier to multiply by the reciprocal. So I'm going to keep the first fraction, and I'm going to change this fraction to improper. So that's going to be 16/19, or negative 19 over 8. And we said that when you divide, it's easier to multiply by the reciprocal. So keep the first fraction, change the multiplication, and use the reciprocal of the second. Notice I'm keeping my negative sign in the numerator because it works out easier, because a negative times a negative is going to give me a positive. Multiply your numerators, negative, over the multiply your denominators. You get positive 32 over 19, which is your final answer, but it's improper, so you're going to change that back to mixed, which is 1 and 13/19. And the last 3 questions are your story problems. It's the temperature change from 3.5 degrees to negative. So the first thing you're going to do is draw your picture. 0 would be right around here if you wanted to put it in there. And it went from here to here. So the difference between here and here, difference between there is your subtraction. So the difference between here and here, or more importantly, since it ended up here, the difference between here and here, that's the one we'll actually use, I think. The difference between those two temperatures, this is difference, subtraction. If I keep flip change, I end up with a difference of negative 14.75 degrees. That's how far it is from where it started to where it ended. And this took place over 6 to 7, 8, 9, 10, 11, 12, 1, 2, over 8 hours. So therefore, the difference in temperature divided by the number of hours equals your mean, in which case, if I grab my calculator and say, what is 14.75 divided by 8? The answer is 1.84375, or approximately negative 1.8 degrees Celsius per hour. That was the change in temperature, the average change in temperature, or the mean change in temperature over each hour. If you had a positive 1.8 degrees Celsius, that's okay too. It's still a change in 1.8 degrees Celsius, whether it be positive or negative, it doesn't really matter. Question 19 is Alex, Bobby, and Claire's money. So we know that Claire has $128. So really what we're saying is the total money will be A plus B plus C, Alex plus Bobby plus Claire. Alex has 3/10 as much money, 3/10 of Claire's money. Oh, 128, sorry. Oh, right. 3/10 of Claire's money. That is going to be Alex's money. Plus Bobby's money is 1 1/5 as much of Claire's money. And then you have Claire's money, which is 128. So that statement, 3/10 of 128 plus 1 1/5 of 128 plus 128, is the statement that represents all of their amounts of money. 3/10, so if I take 3 over 10 multiplied by 128, obviously a simpler way would be to multiply it by the decimal, 3/10. So we go 128 times 3/10. I get $38.40. $38.40, that's Alex's money. plus 1 1/5 is like 1 1/5, which is 1.2. So I can either use the fraction or the decimal, which of course is a lot easier to use the decimal. 153.60 is what Bobby has, plus $128, which is what Claire has. So if I add those three together, grab my calculator, there's Bobby's money already there. Add in Claire's, which is 128. Add in Alex's, which is 38.40. And your final answer is all three together, therefore have $320. And your last question is the plane. What is an expression that represents the change in altitude? So first of all, if we wrote this as a picture and we started this with the plane is at an altitude of 5.5 kilometers. But since these are in meters and these are in meters, we're going to change that to 5,500 meters. Therefore, my units are all going to be the same. It ascends first. It goes up at a rate of 10.5 meters for 30 seconds. And then it goes down at a rate of negative 5.1 meters for 5 seconds. Right? That's our picture. So if we write that as an expression, it's going to be 5,500 meters or 5.5 kilometers. We don't need our m there because it's mathematics. We don't need that. We're dealing with meters. Plus, in brackets, if you want, 10.5 or a positive 10.5 going up 10.5 for 30 seconds per second. Plus, it's going to be going down for 5 seconds. So there's our expression that represents all of the integer changes. If I was to solve it, 10.5 times 30 is 3,000. I better do this on Sunday morning. I can't do this. 315. So 5,500 plus 315 plus negative 25.5, because I can do that one in my head. When you add all those together, plus 25.5 negative plus 5,500 or 5.5 kilometers is 5,789, 5,789.5 meters. And therefore, the plane is now 5,789.5 meters above the Earth. Some people had a negative number there for their answer, in which case the plane would be through the ground and underneath the Earth's crust, which is practically impossible unless it really crashed. So, okay, there's your practice test. Hopefully you guys are ready to write it on Tuesday's retest. Tuesday will be available at lunch or after school, depending on which one you're available for. Let me know on Monday if you need extra help after school. I will make myself available to tutor. And then Tuesday you can write your retest. Good luck to everybody.